Now we talk about conditional probability. If we have more information, it might be possible to shrink our sample space omega and therefore get a better idea of the probability. So let us see this. So say you have a family which has 2 children and you are given the additional information that one of the child is a boy. So this is the symbol for a boy. So the question is, what is the probability that the other child is also a boy? Now the sample space changes because we are given information of having a boy. So the sample space now is the first child is a boy, the second child is a girl. So this is the symbol for the girl. The first child is a girl, the second child is a boy, and first child is a boy and the second child is also a boy. Now there are 3 events here. All of them have boys in it because we are given the information that there is a boy in the family. Now all these 3 events are equally likely. So probability of 2 boys, that the probability of this one event out of these 3 events is 1/3. Now in case this additional information was not available, so if we were not told that there is a boy in the family, then we would have a bigger sample space. We would also have 2 girls in the sample space. So now the size of the sample space is 4. So you have 4 outcomes, 2 girls, 1 boy, 1 girl, 1 girl, 1 boy, 2 boys. So the probability of 2 boys is now 1/4 because you are choosing this one event out of these 4 outcomes. So you're choosing one outcome out of 4 outcomes and therefore probability is 1/4. So notice probability is 1/3 here and probability is 1/4 here. That is because the sample space was different, and the sample space was different because we were given additional information. So this prepares us to talk about conditional probability. So what is conditional probability? So given an event B occurs, so there is an event B which occurs with a positive probability, the conditional probability that A occurs given that B has already occurred, this you define as probability of A conditional on B. So this sign is for conditional on, or you can say probability of A given that B has already happened. This is defined as probability of A intersection B divided by probability of B. So this is how you mathematically define conditional probability. Now the logic is the same as the example above, and let us see this logic more closely. So the logic behind the definition is that A occurs after B has occurred. Thus we look for A only in the parts where B is also there. So for example, in this example here, we have restricted our sample space, we have made it omega prime to only that part where there is a boy. So B has already occurred. So here you can say B is that one of the child is a boy. So you could say this is B. One of the child is a boy. So in terms of counting, you have number of elements in A intersection B divided by number of elements in B. So you divide this by number of elements in the entire sample space. You divide this by number of elements in the entire sample space. You get the corresponding probabilities. So again, going back to our example, so your sample space, so this is the entire sample space. We are not modifying sample space here. So the entire sample space in our example was this: 2 girls, 1 boy, 1 girl, 1 girl, 1 boy, and 2 boys. So we had probability of 2 boys is 1/4, yeah, because you have just this one outcome out of 4, so you have 1/4. So now we use the formula here. So probability of 2 boys given at least 1 boy. So this is A. Probability of 2 boys given at least 1 boy. This is equal to probability of A intersection B divided by probability of B. So probability of 2 boys intersection at least 1 boy divided by probability of at least 1 boy. So what is the event at least one boy? So it could be one boy, one girl, one girl, one boy, or two boys. You have to have at least one boy. So that is, you have to have boys which are greater or equal to 1. So we have probability of at least one boy is 3 by 4 because you have 3 outcomes here, and this 3 is here, and this 4 is the size of the sample space, and you have 4 outcomes in the sample space, 3 by 4. Now we want to focus on A intersection B, that is this portion right here. So two boys intersection with at least one boy. So I'm just copying this down here. So you intersect it, you just get this, two boys. So this is just one outcome out of the entire sample space of 4. So probability of two boys intersection at least one boy is 1/4. So that is what we plug in here. This you put as 1 by 4, and the denominator is 3 by 4. So probability of two boys, given that there is at least one boy, is 1 by 4 by 3 by 4, which is equal to 1/3. This 4 and 4 cancel out.